Good afternoon, everybody. We as developers are the custodians of the data that we collect from the consumers that use the applications, the services, and the websites that we build on behalf of the businesses that we work for. And that information are things like attributes, traits, and preferences about those individual users. And that information is critically important to them. It personally identifies them in the real world and online. And when you add that together with other personally identifiable information, such as address information, credit cards, passport information, we need to do better as developers to protect that information. It's incredibly important to our consumers that we look after that data, and we're just not doing a very good job of it. I called this talk today Breaking the Chain because almost on a daily basis, there is a data breach somewhere in the world. And the reason for that is because we are creating these massive honeypots. When we design a Web2 solution, when we centralize that data and store it in a way that needs millions of dollars worth of glue and Band-Aid measures around it to protect it, we are making it a very attractive honeypot for threat actors. This data is getting breached on a daily basis, and we need to do better as developers to break this chain. There was a quote this morning in the keynote that I just want to share with you, in case you didn't see it, that in the age of AI, that we need to become developers of democracy and we need to become developers of society. And I think this is a really powerful message, because how can we be developers of democracy when we're designing systems that lock customer data up in centralized servers? It's actually my data as a consumer. It's my data, and I want to control that data. So we need to rethink the way that we are building systems as developers. The other reason I called this session Breaking the Chain is that it's a cheeky nod to blockchain. Now, please don't get me wrong, I think blockchain is awesome. It's a fantastic way of creating trust in an environment that is generally trustless. But the problem is, do I really want my personal data stored on an immutable append-only log that is publicly readable forever? I don't. That's my private information. And so in that case, blockchain is not necessarily the approach that I want to take. But importantly, there are many other decentralized technologies and standards that we can use to create these compelling applications that give the consumer's data back to the consumer. Allows us to build truly portable data applications with transitive trust that put the user in the center of the ownership and consent of their data and how that data is used. And that's what I want to talk about today. What are those standards, apart from blockchain, that we can use to build this new version of the internet? What are the risks? What if we don't do this? What if we just stay building systems and applications the way that we do today? Well, the big risk is, of course, cost. On average, in 2023, $4.45 million was the cost of a data breach. And some small businesses, 60% of them, would go out of business very soon after a data breach. This is a massive cost to the business, a reputational cost, but also you've got to think about what is the cost to the individual. If your data is breached, you're in a very bad situation. Under GDPR, 20 million euros, upwards of 20 million euros can be the fine. And GDPR is only one example of some of the standards that are being set by governments and compliance agencies to make sure that we do better with our consumer data. So GDPR is just one example that we need to comply with here in Europe. But when you're building global applications, as I'm sure many of you are, especially if you're a global website, you need to be thinking about those, the ways the data is being stored and managed and how you're handling that data in those other regions. So what I want to talk about today are what are the standards that we can use in the decentralized technology space to facilitate rethinking the way that we build these applications. So instead of storing data centrally, actually using open standards that allow us to create mechanisms to allow consumers to own their own data and give them the right guardrails, give them the right applications and tools to protect their data in a way that they are always in the center of every application of every use of their data, to give them full consent and control. And I want to talk today about these particular decentralized technologies that allow us to identify, attest, present, select, issue and share credentials or information or facts about ourselves with third parties. So I'm going to get a little bit technical here. I'm going to give you a complete view, but not necessarily comprehensive view, because there's a lot in this topic and I don't have a lot of time. So I need to give a bit of a primer on the kind of tech stack that we're dealing with here. But before we do, let's center it back to where we are today and see how we can move forward and what the kind of changes that we need to make. So this is a pretty typical website. Some websites out there are still monolithically designed, so one central database in a kind of monolith, but most modern websites use a microservices environment like this. And you'll notice that in the bottom left there, we have a users table. This is where all of the PII data is being stored on behalf of the users in this website. We also have to think as well, it's way more complicated than this, because using patterns like CQRS, for example, will spread the information around the system and not just have it hosted directly just in the users table. But bear with me on that. The problem with this design is data ownership. The consumer does not own that data. The website owns the data. And there is no way for that data to be taken out of that website and moved to another website or application without just the user doing that by themselves. There's just no way. And we've all experienced this in many different ways. Maybe when you change streaming music providers, you can't export your playlists and import those into the other provider. That's just one example. So the consumer doesn't own their data. And also, consent is not granular enough. When I sign up for a website, I'm basically ticking a box to say, I agree to your terms and conditions, and you're allowed to do whatever you need to do with my data. I don't know what happens after that. I've basically given away the value of my data for some level of convenience. So this isn't a great model. I want to change this. What if we were to take that user information and not store it centrally at all? What if we were to take that personally identifiable information and move it to the front end? To actually move it to a personal data store where the consumer owns and is in control of all their data. What would we have to do to build something like that? Now, I know it's a little different to the way we design systems today, but this is the point. We have to have a radical conversation here about changing the way that we build these systems. What would we need to do in order to facilitate that, and how can the decentralized technologies help me? I want to move from this world where users log into a central database. That's a central solution. And I want to move that across into a decentralized solution where we turn that on its head. And in fact, the websites log into the user. So the user presents a data API out to third parties and consents to giving access to their data. So what would that look like? Again, I have to give you a bit of a primer on some decentralized technologies. So let's start with the first four. How do we identify, attest, select, and present facts about myself? A decentralized identifier is a globally unique identifier that can be created by anybody. It's an open standard. There is a lot of tooling out there to allow this to happen. And a decentralized identifier can identify an individual or a company or a community or even an AI bot. So a decentralized identifier, the important part here is that it is a URI format, and similar to a URL where you can drop that into a web browser and resolve that to a web page, you can resolve a URI into a DID document, which describes the connection between the decentralized identifier itself and the cryptographic material that is used to unlock it. So some DIDs are a little bit different. They're generative, meaning that they don't have a DID, a link to a DID document. They can be derived from the DID itself. But you get the general idea. So why this is important is because the DID itself basically represents the public key of that identifier. And the controller of that identifier, which is the user themselves, has the private key. Now, we are already using this technology every day. Whenever you use passkeys, you're using public-private key encryption. So this is very similar to that. So the private key that you hold proves that you have control of this DID. Remember that, because we're going to come back to that in a little bit. A verifiable credential is a cryptographically verifiable set of claims about a subject meaning a person or some kind of entity. The verifiable credential can contain any information. It has three main parts. It has credential metadata, which describes the credential itself. It has a set of proofs, which is the cryptographic material. And it has a set of claims about the subject. Now, if we were to map this into the real world, think of a driver's license. Here's a sample driver's license. And it still has those same parts. It has credential metadata, for example, some kind of ID on the license. It has a set of claims about the subject or the holder of this license, first name, last name, date of birth, etc. And it also has some kind of proof. In this case, it might be an embossed part of the plastic that the license is created on, or it could be a hologram or something like that. But it's basically those same kind of components. If we were to map this into a verifiable credential, the VC itself is just a JSON payload that follows a standard, and you can see those three parts there. I want to zoom in, though, on the claims. The claims can represent any information that you want to represent. So it can be information about a particular user's driver's license, or it can be information about a university degree, for example. But what's also important here is that I can issue a VC about myself. So I can attest to something about myself, exactly the same way as a third party can attest to something about me. So a driver's license or a university, that makes sense that they would be the source of truth or the authority to say, yes, I have a license, yes, I have a master's degree. But I am the source of truth for any information about myself. So if I decide I want to tell somebody my favorite color is red, or I want to tell somebody that my shoe size is 45, or whatever that is, I can actually use a verifiable credential to do that. Now you might be thinking, why would I go to all this trouble? Well, from an engineering perspective, I don't like special cases. I want to deal with information that's come from a trusted source or zero-party data from the individual themselves in exactly the same way. I don't want to actually have to design two different systems. These verifiable credentials are tamper evident, which means that if somebody's made a change to the verifiable credential, then the cryptographic proof will tell you straight away that it's been changed, which means that we can implement this transitive trust. We can hand those VCs that have been issued to me and stored in my wallet and hand it on to a third party, and that third party knows that that credential has not been changed and that the claims in the verifiable credential can be trusted. In order to present a verifiable credential to a third party, though, you need to use a different format. The recommended format is a verifiable presentation. And you'll see that the format is very similar. A verifiable presentation has metadata, it has proofs, but it also, instead of claims, it has verifiable credentials, or in fact, parts of verifiable credentials. So you can use a verifiable presentation to select parts of other verifiable credentials in order to satisfy a request for data about you. Say, for example, a website wants to know what is the highest level of education that you have, but also what country do you live in. They may come from two different verifiable credentials, from two different sources, and you can bring them together in a verifiable presentation. The last piece of building block we need to understand is how do you actually select these verifiable credentials? Because you can imagine I could have thousands or hundreds of thousands of facts about myself that may want to be presented. And so how does a verifier, how does a third party ask me for those? There is a DIF standard called presentation exchange format. And you can see, again, it's like a JSON format. And it's very easy for you to express things like, hey, give me the VC that proves that you are the owner of a particular email address. But I want it from a particular issuer because I trust that issuer. So it's very flexible in the way that you can express these. So think of this as a query language. Okay, so those are, again, from a very high level, those are the building blocks that we have to work with. But what I haven't done is talked about the standards of how do you actually share that data. What are the mechanics of actually sharing that data and presenting that data? There are a couple of standards that I want to talk about that sit on top of OIDC, OpenID Connect. And you're all familiar with OIDC because you're using it every day. So OIDC and OAuth and other layers on top of that allow you to authenticate and authorize activity on the internet. So you're using it every day. In the case of OIDC, there are generally three parties: the user, there is a relying party who is, say, a website, and there is an identity provider who owns the identity of the user. The user will hit the website and try and sign in. The website will make an authorization request to an identity provider. Let's say it's Google or Facebook. And then there's a conversation between the user and the IDP where the user is asked to confirm and to also prove that they own the email address. And when that's satisfied, then an ID token is passed back to the relying party. Okay, so that's how it works today. The problem here, though, is that not only is my data locked in when I use a Web2 design, but if I'm using an external IDP, my identity is not mine. Because if Google decided to cancel my email address, I've lost that forever. I have zero control over that. It's actually not portable. So I'm absolutely locked in this environment. So how can we do better here? To put this back into perspective of decentralized tech, instead of an IDP, a user, and a relying party being a website, we can actually rename those. So the user is the holder of a verifiable credential. The relying party is a verifier who wants to check that data is cryptographically has not been changed. And then we have the identity provider being an issuer. So this is the tech stack that we use to actually get an issuer to present a statement of fact about a user. They store it in their wallet. At that point, they are the holder of that verifiable credential. And then at a later stage, if you want to share that information out with a third party, then you present those credentials via verifiable presentation to a verifier. So in this regard, OIDC is flexible enough to allow the user themselves to become an identity provider. So they are testing to facts and their own identity themselves. So let's see how that works. There are two standards that we need to be aware of. To issue, we use OpenID Connect for verifiable credential issuance. And to present, we use OIDC for verifiable presentations. And we also use the PEX query language. So let's see those in action. As a Web2 developer, the easiest way to think of this is that those two standards actually bridge from the traditional way of identifying users on the internet to a more decentralized and modern way that puts the user in control of their own identity. So from a very high level, in order to issue a credential, the issuer would actually create a pre-authorization request for a credential issuance flow. And they would share that with the user, which could be in the form of a QR code, or perhaps it could be a link that they click. At that point, the user will use a wallet to actually prove that they are the owner of the verifiable credential by using their private key to sign that request and prove ownership. That gets sent back to the issuer, who would then be satisfied that, yes, they are talking to the real target of that credential request, and they would then issue the credential, which is stored in the wallet. OID for VP, so this is how we share information from the holder to a verifier. The flow is a little simpler, but again, from a very high level. The verifier makes a request in the form of a PEX query, so that's the presentation exchange query. That's presented to the user, who uses a wallet to find the credential that satisfies that request and consents to sharing that back. And that's shared back as a VP token. What's important here is that this is decentralized, meaning that the verifier doesn't have to go back to the issuing party to confirm that that data hasn't changed or that it's valid, because it's cryptographically verifiable. And also, the information is portable. The user themselves owns this information. There is no third party that's in control of that information. Also, once a verifiable credential has been issued, it can be reused multiple times. It can be sent out to multiple verifiers, again, without having to go back to the original source. So this makes the data very portable and reusable. Okay, so those are the building blocks we have to identify, attest, present, select, issue, and share credentials. But that was a lot. There's a lot in here, and I'm keeping it at a very high level because I don't have a lot of time. And you as a Web2 developer are probably looking at this and thinking, wow, I don't know about that. But this is where Affinity comes in. So Affinity is a startup venture based in Singapore, but with offices all over the world, including an engineering office here in Berlin. And for the last few years, we've been using decentralized technology to solve real-world problems. So decentralized technologies, as you've just seen, OID for VP, OID for VCI, verifiable credentials, etc., to solve real-world problems, such as during the pandemic, the Affinity stack was used to verify the vaccination status of millions of cross-border travelers. So we know this technology works, and we know this technology works at scale. So we're working hard now on a new solution. And that is to address this problem of what we call holistic identity. So when I am out there on the internet browsing websites, I'm leaving a digital trail, a digital footprint, with just little slices of my identity around on all those websites. And again, once I actually give that information out to those websites, I have no control over that anymore. I'm not in control of my own data. I don't own my own identity. And we believe there's a better way. We believe that there is a way that you should have, as a consumer, a 360-degree view of yourself online. Again, I don't have time to go through all of these, but I want to constrain the discussion to those technologies that I just discussed, those building blocks, and see how that we can collect, store, and share our data using these technologies. And the three technologies I will cover in the context of Affinity is OID for VCI for collection, the wallet specification for storage, and OID for VP for data sharing. At Affinity, our mission is to build the Affinity Trust Network, which is an identity meta-system that allows developers to build identity solutions that put users in control of their own data. And we're doing that in a way that it will be an open network, and we're always looking for partnerships in this. But this is the overall vision that we are building, and there are various components that we have in order to bring that to life. I want to run through a couple of those now. Again, a very high level to give you an introduction. The good news is that we have a booth just to my left here, so please, after the session, feel free to come and talk to us in more detail about how we can use these technologies to solve these real-world problems. So the first product I want to cover is the Affinity Vault. The Affinity Vault is our personal data store and wallet combined. It's available in the mobile application. It's also available in browser. And it allows users to implement that personal data store at edge or in the cloud, depending on how they want to work. And it also is a digital wallet, conforming to the digital wallet specification. It allows the users to be in full control of their data. Even in such a way as creating multiple profiles. So you could have an online gaming profile, you could have a finance profile, you could have an online dating profile, and keep your information really well separated, and you know which piece of information is in which profile, to give you more control when you're browsing the internet. Affinity Login is our OAuth compliant, OID for VP compliant, sign-in, sign-up, authentication protocol and implementation. Now, I mentioned before about OIDC. This is how it looks in terms of Affinity Login. It's slightly different. There's one extra player in here. So the user would still go to the website. They would still issue an authorization request to the IDP. But in this case, the IDP is Affinity Login backend, which redirects the call to the user's vault. And the Affinity Vault is then used to unlock and allow the user to give consent to accessing the data in the vaults to prove that they are, to prove their identity, and also to do any data exchange that may be required. So basically, what we're seeing here is the user themselves become the identity provider. We implement passwordless sign-in and sign-up in a single flow, and we've got many other features in the product, including, from a developer's perspective, flexible mapping between the VP presentation format and the standard access token, ID token that you expect in an OAuth flow. Affinity Elements is our internet scale control plane for all of the Affinity technologies. It offers features such as key management, domain management, schema building, all sorts of things that you need to automate and facilitate those technologies that I mentioned before. It's the implementation of OID for VP and OID for VCI that I mentioned earlier is all contained in Affinity Elements, plus much, much more. And you access the Affinity Elements APIs using the Affinity CLI or using the Affinity Portal. And the Affinity Portal is your single pane of glass as a developer. It should look very familiar to you from any large-scale cloud platform basically it's a control plane to give you that single pane of glass view. But you can also automate all of these things that you can do in the Affinity Portal. You can automate them using the CLI or also through our SDK. The Credential Issuance system is our implementation of OID for VCI that allows you to issue statements of facts about individuals as verifiable credentials. What's very important here is that we're following the wallet specification of the European Wallet Consortium. So you can create a verifiable credential using the Affinity stack and actually import that into the Affinity Vault or into any EUDI compliant wallet. And if you come to the booth afterwards, we can give you a demonstration of actually importing a credential created by the Affinity stack into the Vault ID implementation. Okay, there's one big part that I haven't actually addressed yet, and that is I haven't solved this problem of how do we use this technology to move that user database into the personal data store. Well, when we looked at this, we realized that these technologies and these implementations that are out there are awesome, and they solve one slice of the problem, but they don't have an orchestration layer that brings it all together. And it's incumbent on developers to actually go and build that time and time again. And we decided there's a better way. We can actually help developers by building a platform and a protocol that brings this together. So I'm really excited to be able to announce today the launch of the Affinity IOTA framework. The Affinity IOTA framework is our end-to-end implementation of the OID for VP standard and is an orchestration layer to make it very easy for developers to get started using this technology and use this decentralized tech in their Web2 applications. So you can think of an IOTA in this way. Instead of sending your data to the back end and storing it centrally and doing queries on it, you actually send the query to the front end where the data is. So we're decentralizing the way queries work. We're moving the query to where the data is and moving the data in the control of the consumer. In the first incarnation, and there will be many, we are creating this end-to-end framework to allow developers to get started really, really quickly and to put the consumer in control of their data and making sure that they have full transparency and are giving full consent to how they share data and with whom they share data. It's our unified method for getting data out of the Affinity Vault and into any application, including websites. And I like to think of it as shifting right. So we've talked a lot over the past about shifting security left. Well, we believe you should shift right with data acquisition. If it's very easy for you to acquire data from the user's vault with their consent, then ask for the data only when you need it. So don't ask for the data up front when you may not need it yet. Ask for it just in time when you need it. It's our bridge between Web 2 and Web 3 technology. So this is the problem statement we're trying to solve. How do we move that users table into the front end? And this is what it looks like. Very simple, 3 easy steps. On the web page, at the web page load, initialize the Affinity IOTA framework using the Affinity Trust Developer Kit, our SDK. And then at any time in the application's lifecycle, make a request for data from the user using a pre-configured configuration that you use the Affinity portal to set up. And then the user is prompted to give consent for that piece of information. And if they consent, then the data is shared via a WebSocket. Or if you prefer, you can use a webhook to push that data to your backend so you can augment the data yourself and make that available to the front end. We manage all of this for you. It's incredibly simple. This is the code that makes it work. 3 steps. Import the SDK. Initialize at page load in just a couple of lines. And finally, anytime in your application that you want data, you make this IOTA request. Very, very simple. You now have access to decentralized data and using decentralized technologies in your application, whether it's Web 2 or not. So the Affinity IOTA framework allows us to build these new ways of thinking about application architectures, to build an Internet of Trust architecture that ensures that the consumer is in control of the consent boundary and not some third-party web application. I'm running out of time to go through all the things that we have here. The Affinity stack is broad and rich. There's a lot going on here, and I really do suggest you come to the booth and ask us more questions to get some more clarity on any of these parts here. But as part of the Affinity Trust Network, we are just building this bridge between Web 2 and Web 3 and those decentralized technologies, such as some of the ones that you see here. Also a sneak peek, we have many more features coming up, including Affinity Messaging, which is our implementation of DIDComm v2.1. We will be open sourcing this, and we will obviously be adding on top of that as part of our end-to-end Affinity Trust Network framework. But we're going to open source this because we do believe that not only data should be portable, but also these technology stacks should also be portable and open. So come and talk to us about Affinity Messaging and DIDComm. The Affinity Trust Network for developers, as I said, is very deep and very rich. There's a lot of moving parts here. Please do come to the booth just over here and talk to us after the session. We'd love to talk to you and understand your use case and see how that we can help you. So our mission at Affinity is a world where everyone can effortlessly and securely control their data and get value out of that data and have put them in the driver's seat of the data, because it really is their data. The best way to prevent a data breach is to never store personally identifiable information. And with the Affinity IOTA framework and all the other tools that you've seen here today, you can really build applications today that make that a reality. Thank you so much for your time. Enjoy the rest of the conference. Come over to the booth and have a chat to us. Have a great rest of the day.